Namaste students, welcome to RSV Group of Schools YouTube channel. I am Umesh Bharadwaj, your science teacher, and today we are going to start chapter 11 Forces and Pressure from class 8 science. This is part 1. In this part we would talk about definition, types, examples of different types of forces. So let's start today's video with the discussion of term force. What is a force in fact? Force is a push or pull on an object. A push or pull on an object is called force. In everyday life, we come across number of actions which involve force. For example, pushing, pulling, lifting, stretching, bending, twisting, they all involve force. For example, we push a trolley to move forward, we pull a drawer, lifting of a bag, stretching of a rubber band, bending a plastic scale, or twisting wet cloths to squeeze out water from it are all examples of force from day-to-day life. So what is force in fact? A push or a pull. Force is a vector quantity as it has both magnitude and direction. Formula to calculate force is equal to the product of mass and acceleration, where m stands for mass, a stands for acceleration, and the SI unit of force is Newton, in the honor of scientist Isaac Newton. Now, what are the effects of force on a body? Force is an influence that can produce many changes in the body. How? Let's see. Force can bring motion in the stationary object. If you kick a football, the football will come in motion. This is the example of a force that brings motion in a stationary object. If you push a trolley, the trolley will start moving forward due to the application of force. So force can produce motion in the stationary or the object at rest. A force can stop a moving body. A force can stop a moving body. For example, if a rider stops pedaling the bicycle will come to rest due to the force of friction. So this force of friction stops the motion of a body. Similarly, a ball rolling on a ground will come to rest after some time due to the force of friction. So force can stop a moving object. Force can also change the speed of a moving object. If a child is riding a bicycle and someone push him from the behind, then what happens? The speed of the bicycle increases. This means the force can change the speed of the moving body. Force can also change the direction of the moving body. In the cricket match, when the batsman hits the ball with bat, then the direction of ball changes. This is the example that how can the force change the direction of the moving object. A force can also change the shape. If you take a balloon or a rubber ball in our hands and press it from both the sides, then its shape changes from spherical to oblong. It means the force can change the shape of the body. So these all are the effects or influence of the force. Force is not seen, but its influence is seen in these ways. Now we will talk about two types of forces, balanced forces and unbalanced forces. What are balanced forces? Let's see. If the resultant of all the forces acting on a body is 0, in other words, I would say if the net force acting on the body is 0, the forces are said to be balanced. As you can see, I have shown an object. It may be a box lying on a table. When it is under the influence of two equal and opposite forces, 5 Newton force from this side, 5 Newton force from that side, then these both equal and opposite forces will cancel each other. And the net force acting on this object would be 0. Net force acting on this object would be 0 because these two equal and opposite forces will cancel out. Thus this object will behave as no force is acting on it. This is the example of balanced forces. Balanced force can maintain the state of rest of an object or the state of uniform motion of an object, but cannot produce any change in it. Now let's talk about unbalanced force. When the resultant of all the forces acting on a body is not equal to 0, then the forces are said to be unbalanced. For example, let us consider this object which is a heavy box and 10 Newton force is applied from this side and 5 Newton friction is applying from that side. Then what happens? Out of this 10 Newton, 5 Newton will be cancelled out. And what is the net force acting on this object? Only 5 Newton. So the net force acting on this object would not be 0 in this case. Hence the object will move in the direction of greater force. So which force is greater? This force, and the object will move in the direction of the greater force. Such force are called unbalanced forces. So in this video we have talked about the introduction, definition, effects and balanced and unbalanced forces. Now we will talk about contact and non-contact forces. What is meant by contact force? Contact force means when two objects comes in contact with each other, then only the influence of force work. This type of force is called contact force. This would be clear from a simple example. Muscular force is a contact force. If I want to push a trolley, I have to touch that trolley with my hand, then my muscles will contract and relax to apply force on that trolley, and then the trolley begin to move forward. So this type of force where we need to touch the object to apply force on it is called contact force. We cannot lift a bag without holding it. This is also the example of contact force. So muscular forces are contact forces. And we do so many activities in our day-to-day life like pushing, pulling, stretching, bending, lifting, twisting. They all involve muscular actions. Hence we can say that muscular force is a contact force. What is another example of contact force? Friction force. You know, friction works opposite to the motion of the object. I told you that when the ball is moving on the ground, then after some times it comes to rest because of friction acting between the ball and the ground. Similarly, if a rider stops pedaling the bicycle, then the bicycle would come to rest due to the friction between the tires and the road. So friction works only when there is a contact between two bodies or two objects. Without that, friction cannot work. Friction is the opposing force, means it opposes the motion of the object, it decreases the speed of the moving object. So these are two examples of contact forces. Now what about non-contact forces? Non-contact forces are those where the contact between two bodies is not required. They can work without contact from a farther distance even. For example, we have magnetic force. Magnetic force exists between poles of magnet. You know that every magnet has two poles, north pole and south pole. And you have studied in your previous class that like poles repel each other while unlike poles attract each other. So here you can see two magnets which are facing each other with their south pole. So what would happen? There would be repulsion because like poles would repel each other. But they can repel from a distance. There is a distance between them. No contact is necessary. Similarly, if we consider these two magnets with their opposite poles facing each other, then what would happen? They attract each other. But this attraction can also happen from a farther distance. Though we have to keep the another magnet in the area of the magnetic force, then this force will work. But contact between the two magnets is not required. They can work even from a distance. That's why magnetic force can be called a non-contact force. What is another example of non-contact force? Gravitational force. Gravitational force exists between any two objects in the universe. Yes, this is the force that was discovered by Isaac Newton, and he stated that this force works between any two objects in the universe, irrespective of their masses, shape, size, color, whatever the case may be. Means, here I have shown one example. Earth and the moon, which is revolving around the earth, are attracted to each other by this force which we call gravitational force. In other words, I would say that the moon keep on moving around the earth due to this gravitational pull. Not only this exists between earth and moon, but all the planets exist in the solar system because of this gravitational force which is exerted by sun. Earth is also under the influence of gravitational force. This does not mean that gravitational force works only in the solar system. In this room also, here in the classroom also, every two objects attract each other. It may be two benches, two tables, two chairs, you and me, all attract each other by this force. This is what we call gravitational force. The force with which Earth attracts objects toward itself is called force of gravity. Now, third type of force is electrostatic force. Electrostatic force is the force of attraction between oppositely charged ions. Here you can see sodium. Sodium is a cation and chlorine is forming an anion, and these two atoms have opposite charges, plus and minus. So the force that exists between opposite charges or like charges, and this type of force is called electrostatic force. So due to electrostatic forces of attraction, ions are bound to each other in an ionic compound. Now we will talk about the second part of this chapter, that is pressure. What is pressure? Force per unit area is called pressure. Force on unit area is called pressure. So what is the formula of pressure in physics? Pressure is equal to force upon area, or P is equal to F upon A. By this formula we can easily find out its SI unit. You know, unit of force is Newton and that of area is meter square. So the SI unit of pressure is Newton per meter square, or Nm minus 2. This is Newton per meter square. It can also be written as Nm minus 2. So what is pressure? Force per unit area is called pressure. Formula of pressure is equal to force upon area, that is P is equal to F upon A. We can also write as that P is equal to F upon A. Now unit of pressure is Newton upon meter square, that is Newton per meter square. Now what are the factors on which pressure depends? Pressure depends on two factors, force and area. Pressure is directly proportional to applied force. More the force, more will be the pressure. While pressure is inversely proportional to area. Larger the area, lesser will be the pressure on it. We can take the example. You can easily cut the tomatoes with the sharp knife. Why? Because sharp knife has less area and it applies more pressure on the tomatoes so that they can easily be cut. We can take more examples. Buildings have wider foundations. So due to wider foundations, a large building can remain erect on it, because wider foundation means large area means less pressure. We can also take the example of your school bag students. School bags are provided with wider straps. These wider straps occupy more area on your shoulder and hence they apply minimum pressure on them. So you can hold your school bag comfortably. If these wide straps are replaced by strings, then they would apply more pressure on your shoulder and it would be uncomfortable for you to hold a school bag for a longer time. So these are some examples by which it is clear that pressure is directly proportional to force and inversely proportional to area. Now we will talk about that pressure exerted by air is called atmospheric pressure. Air around us also exert pressure on all the things, and the pressure exerted by air on us and different objects in our surrounding is called air pressure or atmospheric pressure. And the normal atmospheric pressure is written as 1 atm. We write it as 1 atm. Atm stands for atmospheric pressure. 1 atm is the normal atmospheric pressure which is exerted on all of us. Now pressure depends on the height of water column, because fluid also exert pressure. So pressure depends on the height of water column. To understand this, you can also perform one activity. I have shown here two diagrams. This is a water column taken in a long tube and a balloon is tied at its end. Similarly, we have taken another water column whose height is longer than this one and a balloon is tied at its end. Both are filled with water. So you can see the inflation of the balloon. Though the balloons are of same size, but the inflation of balloon is more in this case as it has longer the water column. So pressure exerted by the fluid depends on the height of water column. This is clear from this simple activity. Now liquids exert pressure on the walls of the container as well as in upward direction. Look at this. Here is a beaker which is filled with water and an object is floating on the surface of water. So why does an object float on the surface of water? Because water exerts force in all the directions. Here I have shown through these arrows that water exerts force on the walls of the container as well as in upward direction. Now the force exerted by water in all the directions of the container can be understood by this simple experiment. You can take a water bottle, plastic bottle, make a hole near to its bottom, connect a tube through it and then tie a balloon. Fill this bottle with water. you would see that the water from the bottle goes to the balloon and it inflates. This is because the water exerts pressure on the walls of the container, and this pressure is exerted on all the sides of the container. The force which is exerted by water on the object kept above it is called the buoyant force, and this buoyant force is responsible for providing buoyancy. Buoyancy means tendency of an object to float. So, different objects float on the surface of water. For example, ice cubes also float on the surface of water. A thermocol can float on the surface of water. This is because when you place them on the surface of water, water exerts force on them in upward direction, causing them to float. And this force which is acting in upward direction and make the object float is called buoyant force, and it provides buoyancy. So, this is the meaning of pressure and the effects of pressure around us. Hope you people must have understood the chapter. Thank you.